Okay, so today we are going to learn, or some of this may be review for some of you, but we're going to learn how to identify the number of protons, neutrons, and electrons within an atom. So a little bit of review from just the structure of the atom. So you have within the atom, or the atom is made up of, you have the nucleus surrounded by the electron cloud, which has the energy levels in it. So remember, in the nucleus, we have protons and neutrons. Okay? And protons and neutrons are where the mass comes from. So they both have a mass unit of 1. And that's where all of the mass is located within an atom, is in the nucleus. So protons have a positive charge and neutrons have a neutral charge. Okay. Then you have around in the electron cloud, you guessed it, in the electron cloud you have electrons. And they have no mass, or pretty much no mass, so we don't count them with the mass. And their charge is negative. Okay? So when we're figuring out how many protons, neutrons, electrons something has, we need to take that into consideration when we're calculating these. Okay? So couple ways that we can figure this, or it can be represented. So most commonly, you'll see something that looks like this. It'll look like this. So this is oxygen, O for oxygen, and then it'll have two numbers here. The top number is what we call the mass number, and the bottom number is the atomic number. And on the periodic table, the atomic number is kind of the big number, and it'll be a whole number on the periodic table. So the atomic number will tell you the number of protons. The mass number will tell you protons plus neutrons. So if I know that oxygen has an atomic number of 8, then that means it has 8 protons. So every oxygen atom in the whole universe has 8 protons. And that's how we identify elements. If it has a different number of neutrons, a different number of protons, then it's not oxygen. Now, if I know that the mass number is protons plus neutrons, and I know the atomic number is just protons, then I'm going to do 16 minus 8, so the top number minus the bottom number, and that would give me the number of neutrons. So in this case, this isotope of oxygen would have 8 neutrons. Okay, so this top number, because if it's oxygen, this top number can change. It can have different numbers of neutrons, and that would change the mass. The bottom number will not change if it's oxygen. So this number will always be 8 if the element is oxygen. Now, how do we figure out the electrons? Well, if it's a neutral atom, meaning it doesn't have a charge, then the protons will equal the electrons. Okay? Because remember, if we go back up here, protons are positive, electrons are negative. If it's a neutral atom, they're going to balance each other out. Positives and negatives are going to cancel each other out, and we'll get the same number of each. Okay. Let's say, so in this case, if we wanted to write the protons is 8, the neutrons is 8, and the electrons are 8 as well for this particular atom isotope of oxygen. So if I wanted to do something a little bit different, let's say it was 17,8O. Okay, so now I've changed the top number. So how many protons, neutrons, and electrons are going to be in this one? Well, since it still is oxygen, I'm going to have 8 protons. And it's also a neutral atom. The charge, and I'll do one with the charge here next, but the charge would be up here in this corner if there was a charge. So the electrons are also 8 since they're the same. And then neutrons, in this case, I'm going to do the top number minus the bottom number. The mass minus the atomic number. In this case, it's going to be 9. Okay, so because I changed that, or we added a neutron, now my neutrons are going to be different. Okay. All right, what if we do this? 16,8O. And now it has a charge of -2. Okay. So for protons, neutrons, electrons, since it's still oxygen, protons is going to be 8. Neutrons, I'm going to do 16 minus 8, the top number minus the bottom, and that'll give me 8 neutrons as well. Now, here's where my electrons are going to be different, because now I have a -2 charge. Okay, so think about this for a second. If I have a -2 charge, I know that electrons are negative, protons are positive. If it's -2, that must mean I have more electrons than I have protons, because I have a negative charge. Okay? And if it's -2, that must mean I have 2 more electrons than I have protons. Well, I know I have 8 protons. I have 2 more electrons than I have protons, so that must mean I have 10 electrons. Okay? So if I have a -2, that's going to be mean my electron number is 2 more than the protons. If it was a +2, the opposite would be true, and I would have to take away, I'd have 2 more positives, 2 more protons than I have electrons, and have to change it up a little bit. Okay? So let's do another one. If it doesn't have, let's say it doesn't have oxygen in it. Let's go with calcium, and let's say it's 40-20. So now protons, neutrons, electrons. Atomic number is 20, so that's going to be 20 protons. Since it doesn't have a charge up here, that must mean that my electrons are also the same. And then to find my neutrons, I do 40 minus 20, so that would give me 20 here. Okay, let's try something different. Let's say we have, nickel. So now we have nickel. It has a proton number, an atomic number of 28, so that's got to go there. My neutrons, it's 50 minus 28, which would be 22. Again, I get that from subtracting those. Now I have a +3 charge, so that means my electrons are not the same as my protons. Okay? And if it's positive, that must mean I have more protons, more positive charges than I have negative charges. So, and then since it's +3, it means I have 3 more protons than I have electrons. So then that must mean I have 25 electrons in this case. Okay. If you have any questions, hopefully this helps. If you have any questions, let me know, and I'll be able to help you out.